So the final reaction in this chapter, and one that we're not going to worry about the mechanism for, is allylic benzylic bromination. And this utilizes a reagent known as N-bromosuccinimide, which is this 5-membered ring. But the only interesting part that you should worry about is this weak nitrogen bromine bond. Electronegative atoms do not like sharing electrons. It's the same reason that peroxides are used, or oxygen bonds are weak. This NBR bond will homolyze or readily break apart, and therefore, after that nitrogen bromine bond homolyzes, it will produce bromine radical. So when you see NBS, or if you're given the structure, just think bromine radicals in that solution, so I'm going to use it. So it selectively does allylic or benzylic bromination. And the allylic hydrogens here I've drawn in. And one of those hydrogens can be abstracted to give a radical intermediate. So just think about that bromine in solution as abstracting this hydrogen and leaving a radical behind. And this radical is allylic or resonance stabilized.